Hello, hello, hello. Good morning. How are you all? Is everything all right? Just a moment. So we are starting a new topic today, numerical analysis. Is it audible? Good morning, Ajay. Look, from numerical analysis, you can expect one question in your examination, and the question will come in under part C. So 5 marks question you can expect, and generally a very easy question is given from numerical analysis, provided you need to know about the basics of numerical analysis techniques. So there are several numerical analysis techniques which you need to know. If I broadly classify the numerical analysis techniques, you can say so these numerical techniques which are there in your syllabus mainly classified into 3-4 categories. So the techniques include, firstly, which will be doing finding roots by using numerical methods. Second kind of techniques includes interpolation. In the interpolation, we have Newton's forward interpolation formula, Newton's backward interpolation formula, and Lagrange's interpolation. So interpolation is a thing. Third, we have numerical integration. Numerical integration. And the fourth thing, which is the numerical differentiation. So broadly, these 4 things we need to cover, and in your examination, one of these 4 will come. Okay. Now there are 2 types of equation. So we are starting the first one, finding roots. In the finding roots, we'll be talking about 2 methods, bisection method. A moment. Bisection method or methods of bisection, and the second one is Newton's Raphson method. Newton-Raphson method. These 2 methods we need to cover here. Firstly, we'll cover bisection method, but before that, let us try to understand what kind of equations are there. Firstly, polynomial equation. Polynomial equation, do you know what is polynomial equation? Polynomial equation will contain algebraic function of x. Okay, so if fx contains only algebraic function of x, then the polynomial equation, then the equation is called polynomial equation. This is simple thing. For an example, if you say x square plus 2x plus 3, it only contains the functions of x. It only contains x, so this is a polynomial equation. So this equation can be solved easily. We don't need numerical analysis technique. There is another type of equation, transcendental equation. For transcendental equation, we can solve them via two approaches, either graphical methods or via numerical methods. So what is transcendental equation? In transcendental equation, it will contain algebraic function as well as some other function. Okay, if fx contains both algebraic and other type of function, it may be sine, it may be cos, it may be tan, or any other exponential, or if fx contains both algebraic and other type of function, then the equation is said to be transcendental equation. The image is not coming clear. You should have said, guys, image is not coming clear because the camera is foggy. Wait a second. What happened to my camera, guys? Anyways, not clear now. Something has got over it. Anyways, तो हुआ है कैमरा में. We'll try to fix it. So example, if you take an example, let's say x is equals to 10x. Okay, or x square is equals to e to the power x. So this type of equation is generally solved via graphical methods or numerical method. Is it done? So let us start with methods of bisection. So what we do in methods of bisection, let's say we assume that the root lies between two particular values. Root of an equation we assume between two values a0 and b0. Okay, so bisection means every time the interval will be divided by 2. So if you consider this interval a0 b0, the midpoint will be, let's say, a1. Now the root may lie left side of this or right side of this. Okay, let me tell you the steps, then you will understand it very clearly. This is very easy technique. In methods of bisection, to find the root, every time we half the interval. So let's say the first step, try to find out the interval. Try to find out the interval. Try to find out the interval I0. This is, let's say, A0, B0. So you have, let's say, an equation like this, x square plus 2x plus 3 or something like that. So we need to find out roots. If this is a quadratic equation, you will get two roots. Okay, so let's say one of the roots may lie between a0 and b0. So try to find out the interval I0 in such a way such that f of a0, f of b0, this product is less than 0. It means the root is lying between a0 and b0. The root is lying between a0 and b0. What do you understand by root? The value of x for which the function is satisfied. Okay, na? If any particular function, if you say f of x is equals to, so the function is becoming 0 at the position of the roots. Now let me just give you one example why this condition is being taken. Let's say we are plotting f of x versus x. Okay, now on this line, what is the value of f of x? It is 0. Now let us consider the function behavior like this. like this. You see here the value of the function is positive, here is the positive, here it is the positive, here it is 0. Okay, that is our root, and as you cross, the value of the function becomes negative, right? So on this side of the root, on this side you can see the function value is positive, on this side the function value is negative. So whenever we have a root, it means there is a transition from positive to negative or negative to positive, right? So what we are doing, we are considering a range, we are considering, let's say, a range between around that root. So this is our root, and let's say this is B, this is A. So our root is lying between B and A, and you can understand why it is, why this condition f of a naught, f of b naught must be less than 0. Okay, because here the function value is negative, here the function value is positive. Obviously when you take a product, the product will must be negative. That is why we do this. Now what happens if you take such an interval where both the values are positive, and obviously the root is not lying between them. If you take both the values negative, then obviously the root is not lying between them. It is only possible when one root is positive and the value of the function at one point is positive and at the other point is negative. Then only we can say that the root is lying between the two. Is this fact clear? Okay, the second step, find the midpoint. Find the midpoint A1, which is equals to, you see, A naught plus B naught divided by. So we have now two values, A0, A1, A1, B0. Now the root can lie on the left hand side or can the right hand side. How will you decide? You will check the value of the function at these points. If the product of, let's say, A0, A1 is negative, then the root will lie towards the left. If the product of FA1, FB1 is negative, then the root should lie towards the right. And as you keep on doing this, you will get closer and closer to the root. Now select the next interval. Our camera clarity is coming back. Actually what happened now, the temperature was high for a few days, very high. Now the rain has started and the temperature has reduced down. So what happens, inside the camera the air might have getting cooled. Okay, and that is why inside the vapor is coming. It is not unclear from outside. It is the vapor inside of the camera. Okay, I have not done anything, but it is getting clear automatically because it is from. So this thing applies to life also. Sometimes whatever we do, situation does not improve. It's the time which heals everything. So guys, have patience in life. Everything will be all right. Next interval I1, let's say A0 A1. A0 A1, you will take this interval when if f of A0 f of A1 less than 0, or you will take I1 is equals to A1 B0 when if f of A1 f of B0 less than 0. Yeah. Now the same process will be repeated. Next you will let's say A0 A1 you get. Next what you will do, you will find the midpoint by using this formula A0 plus B0, A0 plus A1 by 2. You will get the midpoint, and then again you will check this to get the next intervals. Repeat the process to get I2, I3, 4 and so on. The more steps you repeat, the more closer you get, you reach to the root. Okay. So if the process is, let's say, repeated n times, we either get the root. This is one possibility. We either get the root, or finding the interval, we either find the root or find the interval that contains the root. Okay. Or find the interval that contains the. So can you tell me what will be the interval that contain the root ultimately? Let me show you in this way. So let's say you started from here. Okay. This is A0 and this is B0. And you find the midpoint. This is C1. Then you will check, okay, let's say A1, M, A0, A1. Now you will check, now the next interval will be like this. If I assume that f of A0, f of An is negative, then the root should lie in between A0 and A1. So again you will consider the midpoint A2. This is your A1. A0 is. Now you will again find the product A0, f of A0, f of A2, and f of A2, f of A1. So if you find, let's say, now f of A2, f of A1 to be negative, then you should check the root in this end. A2 and A1. Let's say this is the midpoint A3. Now again A2 and A3, let's say the product is negative. So you will scan here A2, A3, then again is midpoint A4, and by checking you can reach to lesser or lesser interval. So after repeating this process, every time the length is getting divided by 2. So if you repeat this process n times, what will be the interval finally? What will be the interval? Can you tell me? Look, initial interval was b naught minus a naught. Okay, so if you do one bisection, you get b naught minus a naught by 2. If you do two bisections, 2 square. 3 bisection, 2 cube. So if you repeat the process n times, so this will be the interval which is containing the root b naught minus a naught to the power divided by 2 to the power n. Now obviously in this method, when we find the error cannot be greater than the this interval length. You see, the root will either lie in this interval between a0 a1 or between a1 and b0. So the error in no way can be greater than half of this. Can be greater than half of this, means it cannot be greater than this length. Root, it may be either here, na. So if the error is there, so you can get it here. Let's say the actual root is here. You can get it here, here. So the error, it cannot be greater than this. For this also, see, if the actual root is here, you can get here, anywhere. But the error cannot be greater than the half of this whole length. Okay, so this is the logic which we will use to calculate the error. So you can just write it. It is clear that the root the error on the root in the root can never be greater than half of the length of the interval. Which is the midpoint. Okay, so let's say if the permissible error is epsilon, then the number of iterations can be determined by you see, if you repeat the process n times, so this will be b naught minus a naught divided by 2n. This should be less or equals to epsilon. Okay, if epsilon is the error. Now if I take logarithm on both sides, get it like this. So this is ln b naught minus a naught minus n times ln 2 less equals to ln epsilon. Therefore n is negative greater equals to ln b naught minus a naught minus ln epsilon divided by ln 2. So the logic is simple. Here, whatever function you are given, it may be x cube plus 3x square plus 1 equals to 0, whatever it is. So initially, you will check the different values of f of x. Your first task would be to check different values of f of x. And if you see one value is positive, another value is negative, so you can say that the root must be lying in, because this is now where the value of f of x becoming 0. Then you will find the midpoint, you will get two endpoints, you will check the value of the function at those points again, and we will test whether the product is less than 1. If it is less than 1, then you will choose that interval, then you will make it half again, and the process will repeat. Is it understood, guys? Have you understood this method of bisection? Let's solve a problem if you have understood this. Not many questions came previously from this particular topic, but it is part of your syllabus, so that is why we are doing it. So small topic. Is it done? Okay, try to do this problem. Find the real roots of the equation x cube minus 2x minus 5 equals to 0 by the method of bisection. Okay, x cube minus 2x minus 5. So here obviously f of x is equals to x cube minus 2x minus 5. So we need to find out the values of x for which f of x is 0. That is the root. Roots, what is roots? Roots mean the values of x for which f of x is equal. So we need to find out the initial interval. We are not provided a naught and b naught. We need to find out. To find out the initial interval, we need to check the values of f of x at different point, and we have to find out 2 points. One of them should be positive, another one of them should be negative. Now if you look at this, if f of x equals to x cube minus 2x minus 5, so we can start with different interval x equals to 0, so it is minus, x equals to 1, if you took x equals to 1, it is again negative, x equals to 2, so if x equals to 2, it is again negative. 2 cube minus 2 into 2 minus 5. So 8 minus 4 minus, so this is negative now. But as you take f of 3, it is 3 cube minus 2 into 3 minus 5. 27 minus 6, 21 minus 5, 16. So this is positive. So obviously the root will lie between x equals to 2 and x equals to 3. So the situation is like this. Let's say this value is x equals to 2, this value is, let's say, x equals to 3. Here the function value is negative here, and the function value is positive here. Okay, the function may not be linear, it may be anything like this. So you can see a transition is happening from negative value to positive value in this range 2 and 3. So the root must be lying somewhere. It is not like it will go by 2.5, right? It may go by any point between 2 and 3. So we need to check that. So first of all, we have got 2 and 3. 2, 3. So the midpoint, let's say x naught, we are naming it x naught. So since f of 2, f of 3 less than 0, the root must lie between x equals to 2 and x equals to 3. So what will be our initial guess? Our initial guess, let's say the midpoint, x naught is equals to 2 plus 3 by, so this is 2.5. okay, now our interval, this is one interval and this is another interval, so this point is 2.5. What will you do next? You will find f of x0. What is the value at that point? So f of x0 will be, you see, 2.5 cube minus 2 into 2.5 minus 5. So this will come out around 5.56, 5.6250. So you can calculate using calculator. You see, in your examination you may not be asked to calculate the whole procedure, you may be asked some portion of it, so that you can do it, because calculators are allowed, so they may not give you like too many steps to calculate, but you need to have this idea. If you have the idea, then you can easily solve. So if this is positive, can you tell me where does the root should lie? In this or in this? Let's say this is 1, this is 2. Where it should lie? In 1 or in 2? In 1, right? Because f of 2 is negative, f of 2.5 is positive. So the root should lie in this interval. So f of 2.5 into f of 2 is negative. So second guess, what will be our second guess? This was your initial guess. What will be your second guess? So after x0, let's say the second guess is x1. So this is our new interval. So x1 will be between 2 and 2.5. What will be your x1? x1 will be 2 plus 2.5 by 2. This will be 2.25. Now if you calculate f of x1, this will be how much? You can put the values. F of 2.25, so this will come around 1.8 and it will come out to be positive, greater than 0. So if this comes out to be positive, it means the root is lying between 2 and 2.25. So what is happening? The range is getting narrowed down. So it will act like a funnel, right? Initially you started with this. So as you keep on doing the steps, so the range will get reduced. Okay, so we are getting close to the actual root. So this is how bisection methods works. Every time you do the iterations, you will get closer and closer to the actual root. Now you can ask, sir, why we are doing all this? We know that how can we know how to find a root. If I am giving you an equation, you can easily find out roots. Okay, x square plus, let's say, 2x plus 1 equals to 0. So what is the root? You can see x is equals to -1, right? X plus 1 whole square equals to 0. So what is the root? X equals to -1, isn't it? But the problem is this situation may not be so straightforward. So if you are given such a function for which the roots are not evaluatable, for which the root you cannot evaluate in this algebraic method, in that case you need to take up this numerical method. Okay, so this, let's say it is not solvable, the roots cannot be found by using this algebraic method. That is why we are taking up this lengthy numerical method. Most of the time, like as a student, we are learning, so we are just learning how the process is going on. But for research purpose and all, this is done by the programming. Okay, if you feed the programming that this is the case, you will choose this range, you will check the values at these 2 points. If you find the product of the functions on the two values is negative, take that interval, then further divide and repeat the process. So you just write a program, and the computer will we can do much more iteration than you. If you do, let's say, 5 to 10 iterations, you will get tired, and it may not be humanly possible, because as you can see, as you go higher and higher, you see then the accuracy is getting improved, but it will become, it is up to 1 decimal. After the decimal, 2.5, next root 2.25, the other roots will be like more number of decimal points will be included. So humanly we have limits, but when the programming is doing, they can do, let's say, 1000 iterations or more than that. So numerical analysis techniques is mainly done in the simulation or in this programming. Let me tell you, this numerical analysis technique is very essential for research also. If you go to PhD, there may be a mandatory paper for numerical analysis. So don't think that this is the end of numerical analysis. You need to study numerical analysis in the upcoming years also, if you are planning for PhD. Okay, anyways, we are getting deviated from the topic. So we got our second guess, x1. So the root must be lying between x0 and x1. So in this way, if you repeat, then you will take the third guess. Third guess will be your x2. X2 will be how much? So 2 plus 2.25 divided by 2. So this will come out around 2.125. Okay, 2.125. Then you will check the value of f of x2, f of 2.125. So this will come out to be negative, sorry, positive point. You will check the value, you can use the calculator, 0.3457. but in your examination they may not ask you to like find number of iteration. They may ask you like up to 2 iteration, what is the value of root. In this way question may come. Okay, so you may be asked to find out this value, 2.125, 2.125, whatever you come. If you repeat this process, you will ultimately reach to one value. So it either may be the root, or this can give you the interval which contains the root. Is it understood? So ultimately you will after doing 11 iterations, you will get around 2.094 approx. So this is just for your reference. Question did not come from this, I think, but it is part of your syllabus. So is it understood overall? Harry, Ajay, Murli. Let's go to Newton's Raphson method. In Newton-Raphson method also, the same concept is there. The concept is, let's say this is the exact root which you do not know. This is your exact root, and we take an initial guess, and from the initial guess we slowly try to approach towards the actual root, real root, and this is the initial guess or approximate root. So this process is better and simpler. So and question come from this. Let x is equals to x naught be an approximate value of one root of the equation. Let's say f of x equals to, if x is equals to x1 is the exact root, then what should be there? F of x1 should be equals to how much? 0. Okay, this is x1. Root means f of that point would be equals to 0. So you understand, like this is our actual goal x1, and we make a guess x0. Now you can ask, why sir, why should we make a guess? Because we do not know x1, this exact root we do not know, we need to find out. Okay, so we have to take the root which is very closer to the actual root, x1 minus x0. This quantity is very small. So you will get a rough idea that the root may lie near about this but not exactly this. So we can say that x1, the actual root, it is slightly away from the approximate roots. X0 plus h equals to x1. Let us write it in this way. So f of x1, because x1 is the real root, f of x1 should be 0. It means f of x0 plus h should also be 0. Now, once we get f of x0 plus h equals to 0, we can expand it in Taylor series. Expanding f of x0 plus h by Taylor's theorem. What do you get? देखो, f of x0 plus h, if you expand via Taylor series about x equals to x0, f of x0 plus h by 1 factorial f prime x0 plus h square by 2 factorial f double prime x0 and so on, this is equals to 0. Now if h is very small, the higher parts of h square, h cube and all those things should also be 0, should be neglected. You can imagine in this way, h is very small, let's say h equals to 1 upon 10,000. So it is a very small number. If we consider h square, it means 1 upon this. So this is very small. And if you take h cube, then it will be even smaller, right? So you can consider it in this way. So we can say that f of x0 plus h by 1 factorial f prime of x0, it is approximately equals to 0. Why? Because since h is small, all higher orders of h containing terms will be negligible. अच्छा, इसको ऐसे लिखते हैं, all terms containing higher orders of h. That is, I think, more that is a better language. Since h is small, all terms containing higher powers of h will be negligible. Okay, so now we have got f of x0 is equals to h into f prime of x0. From this we can get the value of this h minus f of x0 divided by f prime of x0. So this is what we require, x0 plus h. If we can find out h, we can reach to x1. So this is our goal. So h we have got, so x1 is equals to x0 minus f of x0 by f prime of x0. Can you write it? Okay. So we make an initial guess, let's say x1, x naught, to go to the exact root. Let's say we are getting closer to the exact root x1. Now if f of x1 is equals to 0, then there is no issue. Now if you get f of x1 not equals to 0, because we have used an approximate expression, so obviously f of x1 will not be exactly 0, right? So in that case, we'll repeat this process. Then we'll find x2. x2 will be evaluated from this value of x1, which is greater than x0. Getting the point? Look, x0 is the initial value, and from x0, using x0 we got x1. x1 is closer to the actual root, but it may not be exactly the root. From x0, if you repeat this procedure, you will reach x2. It will be closer than this x1. If you do another iteration, you will get closer and closer to the actual root. So in your examination, they will fix like do 3-4 iteration, whatever it will be asked. They may ask you like do 3 iterations and tell me the root. In this way, question may come. So if you repeat this process, we can find out after nth iteration xn plus 1 is equals to xn minus f of xn divided by f prime of x. This formula is known as Newton-Raphson method formula. Clear? Try to solve this problem. If finding the roots, in finding the roots of the polynomial f of x equals to 3x cube minus 4x minus 5, using the iterative Newton-Raphson method, the initial guess is taken to be x equals to 2. In the next iteration, its value is near. So what is given to you? Can you tell me the answer? Look, we have this formula xn plus 1 equals to xn minus f of xn by f prime of xn. So what we are given? X naught. X naught is equals to, in the next iteration its value is nearest. So we have to find out the value of x1 by using this Newton-Raphson method. So how will you do this? If this is the formula, your x1 means n is equals to x1 will be x0 minus f of x0 by f prime of x0. So f of x0 means f of 2. What is f of 2? 3 into 2 cube minus 4 into 2 minus, what is this value? $11. Now f of x is this, f prime of x is equals to 9x square minus 4. F prime of 2 will be 9 into 2 square minus 4. So this is 32, and hence x1 is equals to x naught minus f of x naught 11 by f prime of x naught 30. Okay, 64 minus 11 by 32, 53 by 32. So this will come around 1.65. Option B. Clear? So guys, in this class we have covered the first one, finding roots. In the next class we will be covering this interpolation. The interpolation will be there: Newton's forward interpolation, backward interpolation, and Lagrange's interpolation. Okay, and the assignments will be uploaded, and we'll try to make assignments and we'll share. Okay, so let's end the session here, guys. See you in the next class. Bye bye, take care. Have a great day. Thank you.